Hello, good evening. Good evening, students. Can we? I think we just went live now. We've been having little. I don't know how many persons are here. Kindly, kindly indicate. Can you hear me, please? Can you hear me? Come check this now. Can you hear me? Okay, fine, fine. I think we're good to go. Um, Sorry for the delay, but I'd like you to. I don't know if you can see the board. Can you see the board? Need to be seeing their responses. Comment if you can hear me or see the board, please. Comment if you can hear me or see the board. No, I can't. Okay, fine. I need to check the responses. Come on, assist. Comment if you can hear me or see the board. Okay. Okay, fine. Um, Here at the board, I think we already know what we are here for. This is Biomedical Electronics MLS 321, and we've actually been making attempts to. Okay, we've actually been making attempts. Come check pop out chat. I think I need to use it. Okay, okay. So we've actually been making attempts to start this because this appears to be a solution at this time. This appears to be a solution at this time, considering the present challenges we're having, and we have to break even regardless. So we've been working out this, and much thanks to the crew and media crew that have been assisting us to set this up, and also thanks to your course rep for his cooperation and actually seeing to ensure that this is done. So please, as rightly informed earlier on, I said we'll be taking attendance here. So it's very important that you drop your names and mark number as you participate in the class. And then I said that any lecture that we take online, we are not going back to it. So it's very important that people should have subscribed for this time that we've been asking you to do that, so that when we take lectures here, we know we are done with that. So it's very, very important. Um, so quickly, I've introduced this lesson. Excuse me, please. Okay, so we've introduced this course previously, and we did a whole lot then when we introduced the course Biomedical Electronics, and I think yes, I think we were able to introduce the concept of biomedical electronics, and I rightly mentioned the importance of the course to a biomedical to a medical laboratory scientist, pardon, and I also gave us the course outline, the course of the learning previously. Please assist connect the laptop. So we also took attendance that very day. So I would like to just touch a few things before we proceed that day. Just for the emphasis, remember from the course outline, we said we are looking at principles of applied and general electronics and mechanics of electrical circuits, fault finding, care and maintenance of common electrical equipment in laboratory use, workshop practice, principles of use, principles of use, um, maintenance and repair of common apparatus and laboratory equipment. We're also going to be looking at DC current and resistors, DC current and resistors, capacitors, potentiometers, and resistor boxes, galvanometers, and avometers, solenoid, rheostat, and transformers, thermostats, semiconductors, and rectifier fillers, PMT, photomultiplier tubes, and scintillators, then improvement on existing equipment, review and modification of laboratory methods. These are the things that are contained in the course outline, as we rightly discussed earlier on. And then I mentioned that I mentioned that you cannot actually properly understand medical electronics without understanding the basis. which is electronics. What is electronics? We were able to arrive at a decision or a definition that day that electronics is simply the motion of electrons, the motion of electrons in an integrated circuit. Because we realized that before you can have electricity that day, you always come in contact with positive and negative static charges. And as a result, electronics involves the movement of electrons in an integrated circuit. The positive charges do not move. The positive charges do not move, but rather the negative charges move. So the positive static charge is always caused by electrons moving away anywhere or elsewhere. Materials that loses the electrons lose some negative charges and is left with an equal positive charge. So we also came up with the law of electron movement, where I said that like charges repel while opposite charges attract. We know all of this. Then we also resolved that day that electrical charges can move easily through some materials. Electrical charges can move easily through some materials. So, and we'll, in the course of the lesson, we're also going to be looking at the type of materials that permit motion of electrical charges. So, please just permit us with all the little distractions we are trying to have today, because with time we'll get more used to using this. So just bear with us. What's going on? Stuff is out. Close it. Okay. So quickly, basic electricity concepts and terms. Basic electricity concepts and terms. Um, Before I move into basic electricity concepts and terms, let me quickly ask some questions. Let me pop out some questions for us, and so that you can just give it a try. I don't know. I'm trying to get our responses here, but you can just take down some of these questions, then kind of warm up questions. Hmm? Okay. They can see everything. Okay, fine. I can just assist for and we could just use it to to refresh our minds, attract or repel one another. Do similar charges attract or repel one another? So while you are looking at those warm-up questions, while we're looking at those warm-up questions, in fact, these warm-up questions, you could actually take them down, make responses, and then bring it to class, or you answer them. I would direct you what to do with them, but keep it. Now, quickly before we move, let's go to basic electricity concepts and terms. Basic electricity concepts and terms. Because having defined biomedical electronics and then understood the meaning of electrons and how they move in a circuit, then we need to quickly define basic. Good. This is where we at the moment. Please just hold on for a while. You can come in now. Hello? Okay. Okay. You can now comment. I think we've done something on the comment section. So you can now comment. I think we'll view it. Constable, thank you for the update. So let's get into definition of basic electricity concepts and terms. Please comment so that we'll be sure that the comment section has been is open so that we will actually flow. We'll begin at this point by looking at some basic quantities in electricity. And what are basic quantities in electricity? What are basic quantities in electricity? The basic quantities in electricity includes one, the concept of resistance, voltage. I'm not seeing anything now. Resistance, voltage. Please, I would like you to comment so that we'll be sure that actually the comment section is open. We see concepts like resistance, voltage, current, direct current, alternating current, and power in that order. Most times, the symbols of these quantities and their units are used on equipment, and students need to know these quantities. Of course, remember, I told you that one of the importance of this course to a medical laboratory scientist is that you are going to be using equipment for two purposes: diagnostics and therapeutic purposes. So when you are using this equipment, basically in the operation of this equipment, you are going to be seeing a lot of electrical and electronic symbols, because these symbols actually tells you the quantity that you can either use, you can either troubleshoot, or you can either handle. Take for example, everybody knows the power button on their phone, on their devices. If you bring out your phone, you look at the power button. It is the symbol that helps you know that this is actually the power button. Fine. So we are going to be defining these key concepts. We're going to be defining these key concepts today. And I will start with defining the concept of current and potential difference, or rather what we call voltage. Current and potential difference, or rather what we call voltage. So first, let's define current. Current current is the amount of charge, in brackets, the number of electrons passing a point in a circuit, the time in a wire or circuit charge is carried by electrons. The movement of charges results in current flow. Right? So let's quickly look at that definition, and we're going to be understanding these concepts very well. From there, on the board, we have that current is the amount of charge. When we talk about electric charge, we're talking about number of electrons. Remember that we said that the concept of electronics begins with the movement or the motion of electrons around a circuit. So current is the amount of charge, the number of electrons passing a point in a circuit per unit time. So in a wire, whenever you see a wire, which is a type of material that allows the passage of electrons or current, in wire or circuit, charge is carried by electrons, and the movement of charges results in current flow. So if charges do not move in a wire or a material, current cannot flow. Take that down. Now, quickly, so we have to look at that, and then we ask. So we come out on this. Current is the rate of flow of charge. Number one, I want to give you key points on this. Current is the rate of flow of charge. That's the first. Take note. Then, when current flow past a point in a circuit, current usually flows for a length of time. Current usually flows for a length of time a length time bracket T, which implies that charge, that's the third point, charge bracket Q has passed through the point. Okay. So, Coach, please, due to the challenges we're having, just get the responses. We'll create a group, I think, that for this class, so that anytime we are actually working, we can also be getting responses on the group on the WhatsApp until we fix the comment section. Please let's continue. Now look at this point. First, current is the rate of the flow of charge. That should be taken down, because from the definition we said it is the amount of charge passing through a point in a circuit per unit time. So it is the rate, current is the rate of the flow of charge. That's number one. Two, current flows past a point in a circuit for a length of time. So you see two things now. We are talking about current, I, we are talking about time, current, we are talking about charge. And then when we say that current has passed through a point in a time, that means that charge also has passed through that point. Now, that gives us three key points that defines current, or rather, what I will call the formula of current. So, when you talk about current, permit me to wipe the board. So you see that current equals charge over time. That's the point. Because current is the rate of flow of charge. That's the point. So when we say that current has passed through a length of wire, that means charge has also passed through that point. So current is equals to charge over time. Now recall that current has the symbol I, good, and then charge Q, and time T, small t. So that gives us a triangle. So permit me, that gives us a triangle. That triangle is Q over I times T. I want you to take note of that. So That's it. Dora, is that concept, is that properly understood? You can just send me the feedback on my phone so that we actually know what we are doing. So let me write it well so that you can actually capture it very well. I want you to capture this. I want you to capture these formulas very well. Let it be clear because we are coming with questions. So we say current equals charge over time, which is equals to I equals Q over T. That's in symbols. So when this equals Q over I times T, that's it. I want you to place this very well. Good. Good. Now, let's go ahead. Let's go ahead. Now, the next thing is the symbol of charge is Q. The symbol of charge is Q. The symbol representing current is I. And the symbol representing time is T. Now, every one of us, I know in our O level, we've got used to QIT, QIT, QIT. That formula is, is, is always common, QIT. So I want it to magnet in your mind. I want it to magnet. I want you QIT. So whenever you see QIT, what it takes you back to is the definition of current. Current is simply the rate of flow of charge. Current is the flow of electric charge around the circuit. Simple. So that's it, the rate of flow of charge. So keep that in your mind. Now, if you magnet that, the next thing that you want to look at is this. All these symbols there are measurable. What we have there are quantities. This is current, now this is charge, this is time. Remember, in physics we have the basis of physics begins with fundamental quantities and derived quantities. And these fundamental quantities and derived quantities are measurable. So in electronics or in electricity, these are the quantities that we need now that are relevant to this course. And the first one we are discussing is current. So in the definition of current, we now come in contact with another quantity, charge and time. And so if we are mentioning these quantities, we should also know how they can be measured. Period. So now, what that takes us to the next thing that we need to capture from this formula. Two is that current is measured in amperes. A. Current is measured in amperes. A. That's it. Then the next is that charge is measured in coulomb. And time is measured in seconds. So let's look at that. So what's the formula for current? Current is simply charge over time. I equals Q over T. So we have the compound formula of QIT. You understand that? Now, if you look at this, current is measured in amperes A, that's the unit. Then charge is measured in coulomb, that's C. So the unit of charge is coulomb. And time is measured in seconds, that's S. So that can help us rephrase this whole formula for current. Class, I hope we understand it. So we have, let me wipe this. So we have this, that I A equals, this is I A, then Q C over T S. You get that? So current measured in amperes, charge Q measured in coulomb, and then time measured in seconds. Simple. I want you to capture it. I want you to capture it. Then what else do I want you to know about current? One is that current is available in two ways. Current is available in two ways. It is available as in alternating and is available in direct current. So let me state it. Current is available two ways, alternating and direct. Noted. So current is available in two ways, alternating current and direct current. Alternating current and direct current. Now, I want to say this once more. I want to say this again before we proceed. The more charges that passes around the circuit, that implies that a bigger current will flow. Take note of that. The more charges that passes around the circuit simply implies a bigger current flow. So when more charges pass around the circuit, a bigger current flows. So quickly, using this formula, I would like to try a little exercise for us. I'd like to try a little exercise for us. Yes, I'll call you back. I'm in a class. Hmm. So the more, let's quickly try an exercise with what we have. So I'm wiping the board. Now we can all try to do something. So we say example one. Example one. Dorel, can you guys see the board? Can you see what I'm writing? Are you seeing the board well? Please respond so I will know. Are you seeing the board well? Okay. So it's a battery. Okay. Okay. So, Dorel, I asked a question, you've not responded. Can you see the board well? Can you see the board well? So please, in case you are not seeing the board well, let me redictate that question. Example one. I said a battery charger passes a current of 2.5 amperes. A battery charger passes a current of 2.5 amperes through a cell over a period of 4 hours. How much how much charge does the charger transfer to the cell altogether? How much charge does the charger transfer to the cell altogether?